Dear students, welcome back. This is Dr. Biju Vasudevan. This is the only video for this week 14 for calculus 2, in which we will discuss chapter 9.4 convergence tests, and from chapter number 5 only one topic, a ratio, and no chapter 9.6. Only this is available for your final exam. So remember, for week 14 chapter 9.4 and only one topic from 9.5 will be available for your final exam. That will be discussed in this video. This will be the only one video for this week. Let's start with chapter 9.4. So the topic is convergent test, and the chapter starts with the divergent test. So here we are going to get an idea to test the divergency of the series. If you find a series and its nth term is, find its nth term and the limit of the kth term or kth term, doesn't matter. And if the limit is non-zero, if you get some value which is non-zero, either any non-zero number or infinite, then this series divergence. But if it is zero, it does not conclude anything. The series can be either converges or diverges. For example, if you have a series like summation 1 over 2 to the power k and another series summation 1 over k, isn't it? You see, in both the cases you will find the limit will be 0. You can find here limit of the kth term. K is infinity, 1 over 2 power k. K is infinity, 2 power infinity is infinity, so 1 over infinity is 0. Here summation k from 1 to infinity, see, limit k goes to infinity, 1 over k is 0. Both the cases you're getting limit is 0, but this is convergent, but the second one is divergent. How? This is harmonic series. In the previous chapter we have seen harmonic series is convergent. I'm just going this way. So this is divergent. Harmonic series is always divergent, isn't it? So this is a divergent series, whereas this is actually a geometric series. We will try here. What is the first term? And k is 1. This is 1 over 2, 1 over 2 square, 1 over 2 cube. By the concept of geometric series, you will find this first term is 1 over 2, and the ratio every term is multiplied by 1 by 2. So the ratio is 1 by 2. So the sum of the elements, all the infinite elements, a over 1 minus r, that is 1 by 2 over 1 minus 1 by 2, which is 1. So this series is converging to 1, but the second series is harmonic series is divergent, but both will get limit of the kth term is 0. So when the limit of the kth term is 0, we cannot conclude the series is convergent or divergent. That is the concept. But if it is non-zero, obviously the series is divergence. That's it. Should not be 0. Then it is divergent. That is why this is called divergent. This test says it is divergence or not. Okay, by use if there is non-zero. Okay, and what is the next point here in the theorem? The series UK converges. If the series is converging, then limit should be 0. But the limit is 0 will not give the convergence. The reverse, converse is not true. If it is converging, then limit will be 0. But the limit is 0 does not give the convergence. Just the previous example. Right? Here, what we are going to do is, in this theorem 9.4.3, what's the point here? Two series have been given, UK and VK. Kth term of the first is summation UK, summation VK. There are two convergent series. Then the summation of these two, sum of these two, and subtraction of difference between these two are convergent series. And the sum of these series are related by, so it's given. When two different series are convergent, the summation is also convergent, the subtraction is also convergent. That's the first point here. We will use this technique to solve problems in this exercise set. Second point, when one series is convergent or divergent, when you multiply a constant, it will not change the divergence or convergence. For example, we know 1 by k is harmonic series divergent. When you multiply 5 by k, still it is divergent. Harmonic 5 is common, but still is harmonic series, isn't it? That is it. And here, third point, there is a series which is either convergent or divergent. The divergency or convergency will not be disturbed if you remove some terms. We know that this harmonic series 1 plus 1 by 2 plus 1 by 3, 1 by 4 is going on, isn't it? This is divergent series. If you remove 4 terms that start from 1 by 5 and go on, still this is a divergent series. That's what the point of C. Now integral test. See, in this chapter we have discussed first theorem as divergence test, and now we are discussing convergence integral test. This is another important test. Integral test, what they come to say. You have a series summation uk. For example, I'll take a series here. Summation 1 by k square. What is it? 1 when k is from 1 to infinity, this is 1 plus 1 by 2 square, 1 by 3 square, 1 by 4 square. Obviously this is not harmonic series because the square will change it, isn't it? It's not harmonic series. So this is convergent or not. By using integral test we will check convergent or what. So if there is a series, the kth term you can write here, the kth term is 1 by k square, isn't it? So uk is 1 by k square with all positive sum. So every term is positive term, there is no alternate series, not no negative sign. And if you have a function f is, if you can make u as a function, uk is equal to f of k. Therefore f of k is, therefore what is f of k? F of k is 1 over k square. You can take it as a function f of x now. Instead of k, use x. This is f is 1 over x square. uk becomes f of k. uk is equal to f of x. And conditions have to be verified. This function f is a function that is decreasing continuous in the interval a to positive infinity. A is the value they start from here, isn't it? For some value greater than some value a, we will decide what is the value. Listen, this series starts from 1 to infinity. So let us take a is 1. In the interval 1 to positive infinity, this function is continuous because this is discontinuous only when x is 0. But x is 0 not in the interval. So the function is continuous everywhere in the interval. And it is decreasing. How do you verify decreasing? When x is 1, this is 1. When x is 2, this is 1 by 4. When x is 3, this is 1 by 9. So decreasing. The values of function is decreasing. So this is a decreasing function. Decreasing function continuous in the interval 1 to infinity. So what they come to say, if I write the f of x as an integral from 1 to infinity f 1 over x square dx, if you get a finite number, some finite number, a constant c or any finite number, then this integral converges. If you don't get a finite number, if you get an infinity plus or minus infinity, then the integral diverges, isn't it? So if the integral converges, then the series converges. If the integral diverges, then the given series diverges. So but they say here, read it again, when you can associate the series with the function f of x and in an interval 1 to infinity or some a to infinity, isn't it? Then the function should be decreasing and all the terms are positive in the series, right? And the function should be continuous in the, under all these conditions, both the integration and the series behave same. If they converge together. If they diverge together. That is the point. Remember, there are many points to remember here. The series should have positive terms and the corresponding function should be decreasing and continuous in the left closed interval, and then they behave same. That's it. Now a p series test. P series, actually directly you can try. This result will give you direct answer for many series. When K is in the previous problem we have seen it was 1 over K square. The power of the K, base is K, the power of K is P, changing. It is 2. I can write summation 1 over K3, summation 1 over K power 1 by 2. So now check the P. If the P is greater than 1, the previous case this is 2, we have found it is convergent, isn't it? Check the previous example. Okay, we have found it is convergent. So here I am writing what is it? If in the previous problem we have in summation 1 by K square is convergent. So what is it? The degree of K is 2, which is greater than 1. P is greater than 1, then the series is convergent. Otherwise it is divergent. Because even for K is 1, when K the power is 1, it will be harmonic series, it is divergent. The power of K is 1 by 2, which is lesser than 1, then it is obviously divergent. So the power of K will give an idea. If the power of K is greater than 1, obviously the series is convergent, right? You can write using the concept of this theorem 9.4.5. Now this is obvious, the concept has been already discussed, so you can go through it. I'll go to the exercise set, problem 9.4.3. What is 9.4.3? If two series are convergent, the summation is also convergent, the subtraction is also convergent. That's the point, isn't it? So we can write this one as two different series, sum of two different series, summation K from 1 to infinity. The first series is 1 over 2 power K is given here. Second series, summation K from 1 to infinity 1 over 4 raised to K. Now verify what is the convergence of these two series, and then you can write the answer for one. For first series, K is 1 will give you 1 over 2. K is 2 will give you 1 over 2 square. K is 3 will give you 1 over 2 cube. Is going on. This is a geometric series where first element is 1 over 2 and the ratio is also 1 over 2. Therefore, what is the sum of the elements of the series? A over 1 minus R, which is 1 by 2 over 1 minus 1 by 2, which is 1. So first series converging to 1. Let's in the same way find what is the convergence of second series. Take is again geometry series. Try. What is second series? So first second series says K is 1 will give you 1 over 4, 1 over 4 square, 1 over 4 cube. It's going on. So first number is 1 over 4. The ratio is also 1 over 4. The sum of all the elements will be 1 over 4 over 1 minus 1 over 4. 1 over 4, 3 over 4. The answer is 1 by 3. So the first series is converging to 1, second series is converging to 1 over 3. The summation of these two will be the summation, the convergence of this series, isn't it? So this is 4 plus 1, 3 plus 1 is 4 over 3. The series convergence to 4 over 3. In the same way, we will try second problem. Here, be careful actually. The first term is geometric series, second term needs nth partial sum of the first n elements, and we need to use partial fraction method, of course. We will try. This can be written as summation K from 1 to infinity 1 over 5 raised to K. Second series is subtraction, isn't it? The rule that is in the theorem 9.4.3. Check back. K from 1 to infinity 1 over K times K plus 1. I just take the second series. First series is very easy. You can check when K is 1. What is it? 1 by 5, 1 by 5 square, 1 by 5 cube. It's going on. So first number is 1 by 5. Ratio is also 1 by 5. So what is S? 1 over 5 minus over 1 minus 1 over 5, which is 1 over 5 over 5 minus 1, 4 over 5. So the convergence of the first series is 1 over 4. Very easy, isn't it? let's take the second part, k, and let's take actually partial fraction to separate this one. What do you get? A over k plus b over k plus 1. Now take this one to multiply in the right side. So left side is to be 1, a over k plus 1 plus b into k. When k is negative 1, this term will be 0, this will be negative b, therefore b is negative 1. When k is 0, this term will be 0, and this term, first term will be 0 plus 1, 1 time a is equal to 1. So a is 1. Therefore, thus we can write this term 1 over k times k plus 1 as 1 over k minus b is minus 1 minus k plus 1. Now let us find the nth partial sum. Nth partial sum, because that is the method to find the convergence of this kind of series. So Sn, summation from k1 to n, not infinity now, isn't it? This term k times k plus 1 now will be written as this one, 1 over k minus 1 over k plus 1. Now expand it. K is 1, this will be 1 minus 1 by 2 first term, plus k is 2, 1 by 2 minus 1 by 3 second term, 1 by 3 minus 1 by 4. You see, second term cancels with third term, fourth term cancels with the fifth term. In this way it is going on. So last term will be n, 1 over n minus 1 over n plus 1. So all from second to the 1 over 10, everything will be cancelled. The first and last term will remain. So Sn will be 1 minus the first element 1, last element 1 over n plus 1. So this is Sn. Now we have to find the first series converges to 1 by 4. Second series can be found by using the limit of this term. So what is it? Sn is equal to 1 minus 1 by n plus 1. So limit n goes to infinity, Sn is limit n goes to infinity, 1 minus 1 over n plus 1 will be, second time will be 1 over infinity, which will be 0. The answer is 1. First series is converging to 1 over 4, second term is converging to minus, second series is converging to 1. So this is 1 over 4 minus 1 is minus 3 over 4. That's the end of this one. In the same method, try these two problems. Just separate them and try this one. So this should be written as k plus 1 and k minus 1, and then partial fraction should be used to separate, and then nth partial sum. Okay, find the nth partial sum. This one is geometric series. Again here these two are geometric series. Try by just like the previous method. Now this is p series. Use p series. We know summation 1 power 1 over k raised to p when k from 1 to infinity. Convergent when p is greater than 1. Divergent when p is less than or equal to 1. This is the form, isn't it? Now use this one here everywhere. First case, you can write k from 1 to infinity 1 over k raised to 4 by 3. Here 4 over 3 is your p, which is greater than 1. So this is converges. CGS stands for converges. Next, b. What is the power? Fourth root, isn't it? So summation k from 1 to infinity 1 over k to the power 1 by 4, where p is 1 by 4, which is less than 1. Diverges, dg is c. What is it? Is it 3 over 5 or 5 over 3? How do you write? Summation k from 1 to infinity 1 over k power 5 1 by 3. Third root, isn't it? 5 by 3. Therefore p is 5 by 3, which is greater than 1, so converges. Final one is pi. P is pi. Pi is 2, 1, I mean, what is it? 2, 22 by 7, and 3.14 something, which is greater than 1. So this is converges. That's the end. That's the end of all this problem. Apply divergence test. Divergence test. If the divergence is non-zero, you will say it is divergent. If it is zero, no conclusion, right? So we should remember the kth term, limit k goes to infinity should not be zero to say the series is diverges. Otherwise, no conclusion. Part A. What is it? What is the kth term? K over e raised to k, limit k goes to positive infinity, it will be infinity over infinity. Then in determinate form, you will get differentiate the numerator, it will be 1, it will be e raised to k. Again now apply k goes to, so L'Hopital rule, isn't it? L'Hopital rule. 1 over infinity, it is 0. So when it is 0, no conclusion. No conclusion. Conclusion, isn't it? If it is non-zero, you can say divergence. So here, what is the case? B. For B, limit k goes to infinity, ln k. Ln infinity is infinity, which is non-zero. Therefore, diverges. B is divergent. What is C? Limit k goes to infinity, 1 over root k. 1 over infinity is 0. No conclusion. Because when it is non-zero, you can say divergent. It is 0, there is no conclusion. Fourth one has been left to you. Try yourself. Now you want to try. When k is infinity, this will be 1, non-zero. The polynomial end behavior of the polynomial will give you the power of k is half in the numerator, power of k is half in the denominator. So the coefficients of k power half is 1 by 1. So when you take n equal k is infinity, it will be 1. It is non-zero. When it is non-zero, you say this is divergent, right? So this is very easy. Now confirm that integral test is applicable. Wow, that's the question. Integral test, there are many conditions. The terms should be non-negative. Okay, there is no negative term. First condition satisfied. When you write uk as f of k, what is f of x? Which is 1 over 5x plus 2. This function fails to be continuous only when 5x plus 2 equal to 0, which is x is equal to negative 2 over 5. Negative 2 over 5 not falling in the interval 1 to infinity. So let us take the interval 1 to positive infinity. In this interval, this function is continuous. And of course it is decreasing. You can check when k is 1, it will be 1 over 5 plus 2, 7. When k is 2, 10, 1 over 12 is decreasing. So function is decreasing, continuous in this closed interval, left closed interval from a to infinity, and the terms of the series are non-negative, positive. So we can say that both uk and f of k in the integral summation uk and the integral 1 to infinity f of x dx behave same. Both either converge or diverge. So we have to integrate the function till the answer. So this is an integration. So integration is 1 to infinity. F of x is 1 over 5x plus 2 dx. Improper integral, isn't it? So upper limit is infinity. You will write limit 1 to b integral 1 over 5x plus 2 dx when b goes to infinity. This is when you differentiate denominator, you should get 5 in the numerator, isn't it? So multiply and divide by 5. So the answer is 1 by 5. This is ln 5x plus 2, isn't it? And the limit will be from 1 to b. You should take the upper limit. The limit b goes to infinity. So limit b goes to infinity 1 by 5 ln 5b plus 2 minus this 1 ln 7. What is happening? So when b goes to infinity, this term will be ln infinity, so everything will be infinity. So this series diverges because the integration diverges infinity. Therefore this uk, the series diverges because the integration diverges. Okay. In the same way, let's try b. Try all the properties. All these terms are non-negative. There is no negative, so positive terms, isn't it? And f of x, you can take the uk, which is 1 over 1 plus I write 3x whole square, isn't it? 3x whole square. 3x whole square is 9x square, which is here, right? And this function is decreasing and continuous because for all values of x, f is valid, isn't it? In the interval 1 to infinity. So this is continuous decreasing 3 times x square, right? Continuous decreasing in the interval. So integral test is applicable. Therefore, let's try integral test 1 to infinity f of x 1 over 1 plus 3x whole square dx can be written as limit b goes to infinity integral 1 to b 1 over 1 plus 3x whole square dx. Now take u is equal to 3x, du is equal to 3 dx. So du over 3 is equal to dx. Therefore, this will be, you can find the limits of u as well. Okay, let's be back. Limit b goes to infinity. There 1 to b 1 over 1 plus u square du by 3, which is 1 by 3. Now, which is b goes to infinity. This u, when you integrate this one, it is limit b goes to infinity 1 over 3. This is tan inverse u. What is u? 3x. U is 3x. Tan inverse u. And it is from 1 to b. Use upper and lower limit. Limit b goes to infinity 1 over 3. Upper limit tan inverse 3b. Tan inverse 3b minus tan inverse 3. When b goes to infinity, tan inverse 3b will be tan inverse, so tan inverse infinity minus 1 by 3 is outside. Tan inverse infinity minus tan inverse 3. This will be 1 by 3 pi by 2 minus tan inverse 3, which is finite. Whatever the value you get, finite. So this integral converges. If it is not of infinite value, then it is convergent, isn't it? So this integral is convergent, therefore this series is convergent. We don't want to check where it converges to. This convergent to this point, nothing else. So that's the end of this problem. What is next? We have few more problems to finish this chapter. The series converges or not, that's all. You can, okay, this I am leaving to you, can try yourself, because this one is harmonic series. You can try 3 over 5 outside, that's for k from 1 to infinity 1 over k. When you know this is harmonic series, divergent, multiplying a constant will not change it, so this is diverges. And here what is the test? You can check the divergence test first. The question is converging. What is it? Limit k goes to infinity, kth term is ln k plus 1. ln k plus 1. Infinity over infinity. So indeterminate form, differentiate it. Limit k goes to infinity 1 over divided by this one 1 over k plus 1, which will be limit k plus 1 when k goes to infinity, which is infinity. Therefore this is non-zero. When the limit of the kth term is non-zero, it is diverges. The series diverges by divergence theorem, first theorem, right? Try the same here. If the limit of the kth term is non-zero, this is divergence. Check this. So limit k is infinity, k square plus 1 by k square plus, this is polynomial of the degree 2, both have the same degree, so the coefficient of k square is 1 by 1 when k goes to infinity. It's 1, not equal to 0, so this is still diverges for the Bosch theorem. That's it. Next 9.5, but we have only one test to discuss, ratio test. So straight away we go to a ratio test to solve some problems, isn't it? So let's go to ratio test. What is the concept of ratio test? If we have a series a1, a2, a3 is going on, isn't it? Ak, and the next term is ak plus 1. If you find ak plus, you can talk u1 in this problem is given u1, u2, u3, uk plus 1. Okay, find the ratio between these two. That is the ratio test. K plus 1th term and divided by kth term, and then take the limit of the k ratio. K goes to infinity, first to infinity. If the answer is less than 1, the series converges. If the answer is greater than 1, it is divergence. If it is equal to 1, inconclusive. This method fails. So very simple. Find the ratio of the k plus 1th term and kth term. With the result, and take the limit of the ratio. Limit k goes to infinity. If the answer is less than 1, you say the series is converging. If the answer is greater than 1, you say diverging. If it is equal to 1, this method fails. You can use any known previous method, kind of divergence test or integral test or general, using the geometry series or harmonic series you can try, right? Fine. Ratio root test is not going to be discussed. Let's go to the problems of a ratio test. Okay, I'll take you different tests. Use the ratio test. Okay, use the ratio test. What is the concept of ratio test? Take the k plus 1th term and kth term. Okay. Problem number 12. What is the kth term? uk. This one, 4 raised to k over k square. Now write k plus 1th term. Replace k as k plus 1. 4 raised to k plus 1 over k will be replaced by k plus 1 square. Now what we have to do is take the limit k goes to infinity for uk plus 1 over uk. Limit k goes to infinity, uk plus 1 is this thing, 4k plus 1 over k plus 1 whole square, whole divided by 4 power k divided by k square. Now we can invert the denominator and multiply. The limit k goes to infinity, this first term is 4 raised to k plus 1 over k plus 1 whole square. This one can be inverted, so it will be k square divided by 4 raised to k. See, 4 raised to k plus 1, 4 raised to k into 4, which is 4 raised to k plus 1, divided by 4 raised to k. This is 4 raised to k plus 1, 4 raised to k into 4. So 4 raised to k, 4 raised to k can be considered, you get 4. So this term and this term will give you 4, the numerator. So limit 4 on the numerator. This one is k square, and expand the denominator, k square plus 2k plus 1. Now 4 is constant to keep outside. Limit k goes to infinity, k square over k square plus 2k plus 1. Use the concept of end behavior of the polynomial. The degrees of k are same, isn't it? And therefore the coefficients are 1 over 1. 1 over 1. So what is it? it is 4. So the limit of this one is 1 multiplied by 4. So you get, so limit k goes to infinity uk plus 1 over uk is equal to 4, which is greater than 1. If it is less than 1, they can say it is convergent. If it is greater than 1, we say diverges, DGS. If it is equal to 1, this method fails, right? Okay. Let's see second problem. Problem number 16. What is kth term? What is kth term? uk is given k over k square plus 1. What is uk plus 1? K plus 1 over k square, k plus 1, k plus 1 square plus 1. Simplify this one first before taking the limit. uk plus 1 divided by uk. uk plus 1 is k plus 1 divided by this one, k square plus 2k plus 1 plus 1. This is uk plus 1 divided by uk. This one should be divided or multiply, invert and multiply. Invert k square plus 1 divided by k. So when you multiply this one, this will be k cube plus k square, k cube plus k square plus 1 divided by k cube plus 2k square plus 2k. So let's take the limit now. Limit k goes to infinity. This is uk plus 1 divided by uk is equal to limit k goes to infinity k cube plus k square plus 1 divided by k cube plus 2k square plus 2k. Highest power is 3 and the coefficients are same, so the answer is 1. Therefore, inconclusive. This method fails, isn't it? So this method fails. You are asked to use your the series converges or inconclusive, that's all. So this method is inconclusive. So what method is possible to proceed? You can check integral method. This is all terms are, no, actually in this problem we don't need to apply integral method, but I am suggesting if this method fails, we can try integral test, or first try divergent test. If it is non-zero, you can say divergence test may not be workable. So try integral test to find the convergence. This will be taken as f of x over x square plus 1. You can try this one. So this method you can try to find what is the converging or diverging. You can check. But this method fails. Let's take one more problem from I will write one more problem from your textbook for using a ratio test. What is it? Problem number 15. Summation k from 1 to infinity k factorial divided by k factorial divided by k cube. Is it k cube? Yes. Okay, let's try this one. Problem number 15. What is uk? The kth term. It is given k factorial divided by k cube. What is uk plus 1? Replace k by k plus 1. K plus 1 factorial divided by k plus 1 cube. Now what is the ratio? uk plus 1 divided by uk is k plus 1 factorial divided by k plus 1 cube. Multiply the inverse of the uk, which is k cube divided by k factorial. Now you remember k plus 1 factorial is k plus 1 factorial is 1 2 3 4 up to k and k plus 1. isn't it? So when you expand this one, you will find k and k plus 1, up to k and k plus 1, but k up to k, it is k factorial, isn't it? So here k factorial is 1 2 up to k factorial, k up to k, you have to multiply. What is k plus 1 factorial? 1 2 3 k up to k and k plus 1. So when you divide this term by k factorial, you will get only k plus 1. This and this will give you k plus 1. K plus 1 the numerator. K plus 1 factorial. Out of k plus 1 we will remove k factorial here, isn't it? So it is k plus 1. And here it is k plus 1 cube. K plus, sorry, this one, what is your answer? K plus 1 into k cube divided by k plus 1 whole cube. Now 1 k cube, k plus 1 can be cancelled. You will get k cube divided by k plus 1 whole square. This is the ratio, which is uk plus 1 divided by uk. Now take the k goes to infinity, and remember the numerator degree is more. So what is happening now? So when you find the kth, when you find it, limit k goes to infinity, uk plus 1 over uk, it is limit k goes to infinity, uk plus 1 over uk is k cube over k plus 1 whole square, and the degree of k is more in the numerator, so it will be infinity, past infinity. And the series, therefore the given series diverges. That's it, isn't it? If it is lesser than 1, it is divergent, it is convergent. Otherwise, if greater than 1, even for infinity, it is divergent. If it is equal to 1, no confusion, right? That is for a ratio test. That's the end of the video for week 14. Thank you very much.